Hi everyone. Today we're going to keep talking about quadrilaterals, and the next on our list is rhombi and squares. So let's start with rhombi, or the singular for that word would be rhombus. So if you have one of them, we call it a rhombus. If you have more than one, we call them together rhombi. Now it is a quadrilateral, and the definition of a rhombus is all four sides are equal. Now when I first say that, you probably immediately think of a square. Now a square is a rhombus, but you can also have a shape that looks like this kind of diamond looking shape. So this is a quadrilateral four-sided figure. You can see by the little markings that all four sides are equal, but it's not a square. Four sides congruent, not a square. So here are theorems about rhombi. Number one, I want you to notice that a rhombus is a parallelogram. So everything that we learned from our section about parallelograms applies. That means opposite sides are congruent. Obviously, all sides are congruent. Opposite angles are congruent. The diagonals bisect each other. All those theorems we learned still apply. Now, there are two additional theorems that work for a rhombus that don't work for a parallelogram. The first one says, not only if I draw in the diagonals, not only do they bisect each other, which is true for all parallelograms, they are also in a rhombus perpendicular. So let's draw the diagonals in. Let's connect this corner to this corner, and this corner to this corner. Now, what we knew already, because it's a parallelogram, is that these two are congruent, and these two are congruent. That's true for any parallelogram. What's different for a rhombus is that they make a right angle. So in a rhombus, the diagonals are perpendicular. That's a new rule, a new theorem that applies to a rhombus, but not other types of parallelograms. Now our second theorem says the diagonals bisect each angle. So what that means is that in each corner of the rhombus, the diagonal is actually an angle bisector. So that one's congruent to that one one's congruent to that one, and it works for all four of them. Each angle is cut exactly in half or bisected. And again, that's another one that's true for a rhombus, but is not true for other types of parallelograms. Okay. So let's do an example. I gave us a rhombus, and you can tell it's a rhombus if you look at the picture. All four sides are marked congruent to each other. That's how you would know it's a rhombus, by looking at the picture. Then I drew in the diagonals, and I can see there's a right angle in the middle, which was one of our theorems. And I gave you a couple values. Let's mark those in before I even ask you anything about the picture. I said angle BAE, that's this one right here, is 25 degrees. From B to A to E. Then I said line segment BE, which is here, is 8. And we'll find each measure below. We'll put them all up here for now. Okay, the first thing I want to find, and I'll switch colors here to make it stand out, is angle DAB. Oh, I'm sorry, this is the second thing, DCE. DCE, which is this angle right here. And I'll put 2 markers on it. So let's start figuring this out. Let's think of some of the theorems that we know. Number one, we just said in a rhombus, the diagonals bisect the angle. So if this angle here is 25, the one I marked in red, then so is this one here, 25. Which means if I add them up, this whole angle down here at the bottom is 50 degrees. Now, I look at this top right corner over here, and I say, well, because a rhombus is also a parallelogram, the opposite corners are congruent. So this angle up here is also 50 degrees, and if I cut that in half, each one of these are 25 degrees. So that's another way to think of a rhombus. Not only are the opposite sides congruent, or the opposite corners congruent, when they split in half, they basically make 4 congruent angles. So those are all 25-degree angles. And that's the answer to number 1. Angle DCE is 25 degrees. Okay, let's keep going. Angle DAB. D to A to B. I've already answered that. That's this 50 right here. So angle DAB is 50 degrees. Okay, let's do the length of DE. From D to E is here in the picture, and that's congruent to the one that we already know. Because all parallelograms, and again, this isn't a rhombus theorem, this is something we learned last section. All parallelograms, the diagonals bisect each other. So DE is also 8. And then the last thing I asked you guys to find was BD, which goes all the way from here to here, and with the work we've just done, just add it together. 8 plus 8 is 16. So we used some of our theorems about parallelograms, and we also used our new theorems about rhombus. So just remember, you want to keep these theorems separate in your mind. Which ones are for parallelograms only, and which ones are for rhombus only. And just remember, the ones that work for parallelogram also work for a rhombus. Oh, you know what? There was one more in here. Angle ABE. Let's do that one. So angle ABE, I'll switch colors again, is this one right here. Mark it in green. This is my last one that I'm trying to find. And now I'm going to go back to a theorem that has nothing to do with parallelograms or quadrilaterals or anything. It's triangles. Because I know that I have right angles in the middle, so this is 90. I know that I have a 25, that was the given. And I know that the 3 angles of a triangle add up to 180. So what I'm going to do is I'm going to take those 2 angles, add them up, 90 plus 25. That gives me 115. And then I'm going to subtract that from 180, and that'll be the answer. That'll be my final answer. So we get 65. So final answer for angle ABE is 65 degrees. And I knew that because the 3 angles of a triangle have to add up to 180. So that was yet another theorem that we had to remember about triangles from last module. All right, let's talk a little bit about a square. So remember, the title of this section was rhombi, or a rhombus, and squares. Now, a square is a quadrilateral, 4-sided figure. And what it is at this point, it's like everything we've learned so far. A square is a parallelogram. It is a rectangle. It is a rhombus. Like everything we've learned so far is a square. So every theorem that we've learned so far applies to a square. In a way, it makes it the easiest one, because every rule you've learned so far works on a square. And that's what I said right here. Every theorem we've learned so far this module works for a square. Okay, so for our first example, we got our picture here. And what I said in the directions is that quadrilateral ABCD is a square. That's one way for me to tell you that. It's just actually say it in words. It's a square. Now remember, when I tell you something's a square, I'm actually giving you a lot of information. I'm telling you it's a square, and a rectangle, and a parallelogram, and a rhombus, all of those things. So everything we've learned about any of them works in this question. All right, now let's label what we know so far. We know that AO is 7x minus 13. That's going to be this half diagonal right here, 7x minus 13. And we know that DO, this half diagonal on the other one, is 5x plus 17. So we start thinking about this question. And the other thing is what I asked you to find is AB, which is this side over here. That's what I want to find. Now it's going to take me a few steps to find that. Step 1, let's solve for x. So I look at this question, I want to realize the relationship between these two expressions. Now, because a square is also a rectangle, the diagonals are equal or congruent. And they bisect each other, so what we get, just like when we did rectangles, all 4 half diagonals are congruent. And that's going to be my first equation. If these are congruent, then these two expressions are equal. So I'm going to start this question off by saying 7x minus 13 equals 5x plus 17, and I'm going to solve for x. Okay, let's get rid of the 5x first. I'm going to subtract 5x from both sides. Cancel that one out. 7 minus 5 is 2x. We leave the minus 13, and it equals 17. We will add 13 to both sides. To cancel out that minus 13 leaves just 2x. 17 plus 13 is 30. We'll divide by 2 to cancel the 2's, and 30 divided by 2 is 15. So x equals 15, not our answer, but definitely the first step. So I'm looking over at my picture, seeing that question mark. I'm saying, well, I still can't figure out how long that line segment is. But I can at least figure out the two that I had an expression for. So pick one of them. It doesn't matter which you do. I'll do the 7x minus 13. And I'm going to plug in my answer, which was 15 for x. So I have 7 times 15 minus 13. 7 times 15 would be 105. And 105 minus 13 would be 92. So I just figured out the length of this one right here is 92. Now what that means is the length of all of them are 92, but now's a good time to check your work, because if I plug in 15 into the other one, I should get 92 there also. And maybe I won't write it out, but maybe you do it on a calculator. You do 5 times 15, that's 75. 75 plus 17 does give you 92. So now I'm very confident in my answer. Very confident that all of these sides are 92. But I still have to find that question mark. There's still one more step here. And I think what I'm going to do, let's go back to our theorems. A square is a rhombus, so the diagonals are perpendicular. Which means what I'm looking at here is right triangles, which means if I look at that right triangle over there on the left side, I can do Pythagorean theorem to find the question mark. And that's going to be my last step for this question. I am going to do, let's see if we can squeeze it in here, a squared plus b squared equals c squared. The hypotenuse is the question mark. Remember, the hypotenuse is always opposite from the right angle. So for this question, I'm going to leave the c, and I'm going to plug in the legs for a and b. Now the legs are both 92. So just, I mean, it's 92 squared plus 92 squared. It doesn't matter which one is which. So basically, I'm going to do the next step on the calculator. I'm going to do 92 squared plus 92 squared and see what that equals. I'll pause it and be right back. All right, I got 16,926. 928, actually. 16,928. Now remember, when you're doing Pythagorean theorem, once you've solved for c squared or a squared or b squared, whichever one, you always have to finish the question by taking a square root of both sides to find the letter itself. So we found c squared. C squared was 16,928. That means c is the square root of 16,928. And I'm going to go back to my calculator one more time. Be right back. And I'm going to go with decimal approximation here and say it's about 130. 130.1. So that was a really good question because it took us a few steps. We had to solve for x first, we had to use x to find the side, and then finally we had to do Pythagorean theorem to actually answer the question. But we also used a lot of good quadrilateral theorems in there. We used the fact that the diagonals were perpendicular to make right triangles. We used the fact that the diagonals were equal to solve for x. So there's a lot of good theorems in there.